OAC Textbook Page 331 by Zheng. A 1,000 kilogram plane is trying to make a forced landing on the deck of a 2,000 kilogram barge at rest on the surface of a calm sea. The only frictional force to consider is between the plane's wheels and the deck, and this braking force is constant and equal to 1/4 of the plane's weight. What must be the minimum length of the barge be in order that the plane can stop safely on the deck if the plane touches down at the rear end of the deck with a velocity of 50 meters per second towards the front of the barge? Alright, so the first thing that we have to do is to state our givens. We're given that the mass of the plane is 1,000 kilograms. Next, we're given that the force of friction acting on a plane is 1/4 the weight of the plane. And we can calculate this using the formula force of friction equals 1/4 mg, which gives us a force of friction of 2,452.5 newtons. We're also given that the initial velocity of the plane is 50 meters per second at the rear end of the barge. And since it's at the rear end of the barge, the height will be 0, and therefore we don't have to consider any gravitational potential energy. We're also given that the initial velocity of the barge is 0 meters per second, and that the mass of the barge is 2,000 kilograms. In this question, what we have to do is we have to find how long this barge needs to be. What is the minimum length that this barge needs to be in order for the plane to stop safely on the deck? Let's get started. Alright, so in this situation, we know that it is only the force of friction that slows down the plane. But at the same time, we have to keep into consideration that this force of friction will apply a positive force on the barge that moves the barge from its initial velocity of 0 to a final velocity that is greater than 0. And we can calculate this using the law of conservation of momentum. Now, in the law of conservation of momentum, it says that the initial momentum is equivalent to the final momentum. In this situation, the initial momentum consists of just the initial momentum of the plane, because the initial velocity of the barge is 0, and therefore the initial momentum of the barge will be 0. As for the final momentum of the situation, since the plane stays on the barge, we add both of the masses together and they will share the same final velocity, which is the velocity of the barge. And then all we have to do next in this situation is isolate for VB prime, plug in the values, and we should get a final velocity of the barge is 16.6667 meters per second forward towards the front of the barge. For the second step, we will be using the law of conservation of energy and the work done by friction to find the minimum length of the barge. First of all, the law of conservation of energy states that the initial amount of energy is equivalent to the final amount of energy. In this case, since there is no gravitational potential energy involved, nor elastic potential energy involved, we are only dealing with kinetic energy. Next, we know that there is energy loss due to the work done by friction, and we have to keep this into consideration in our equation. So we know that the initial amount of kinetic energy must equal the final amount of kinetic energy plus the work done by friction. Let's expand out the equation that we got. For the total amount of initial kinetic energy, it will consist of just the initial kinetic energy of the plane, because the initial velocity of the barge is 0, and therefore the initial kinetic energy of the barge is 0. As for the total amount of final kinetic energy, since the plane stays on the barge at the end, they will share the same kinetic energy. So we add both of the masses together and they will share the same velocity, which is the final velocity of the barge that we found in step 1. As for the work done by friction, the work done by friction can be calculated using the force done by friction times the displacement. Now the force of friction acting on the plane will ultimately cause the plane to stop. So the displacement describes how far the plane will go before it comes to a stop. And in this situation, this will give us the minimum length of the barge for the plane to stop safely on the deck. Now we just plug in the values and then solve for delta D. And we will get an answer of 339.79 meters forward. Therefore, the barge must have a minimum length of 339.79 meters for the plane to stop safely on the deck. Thank you for listening, and I hope that you now know how to solve OAC Textbook page 331.